Hello everyone, welcome back to channel. So today's problem is minimum window substring. So today is day 7 and this problem also builds on the previous problem. In the previous problem, what we were doing is we were trying to find the maximum window. But in this problem, why I have also written it as most important, because we're trying to find the minimum window here, or as soon as the condition is satisfied, we will shrink the window. So in this you have given a string S, which is the smallest substring, okay, which is the string S and a T, and you have to find the smallest substring of S that contains all characters of T. So in this, why I have written this is the biggest mindset change, because earlier we were doing find maximum window, but in this problem what we will do, find the minimum window or shrink as soon as condition is satisfied. So the core idea is we take the record like build, some name I have given, which has a string and a number, and we expand the window, try to match all characters. Once matched, we shrink the window. Why this is important also, this problem, because it combines your map, sliding window and optimization. Okay, now let's move to the code part one by one. So in this, what I have done is you have a minimum window function which takes a string S and T characters we must include. Okay, so in TypeScript, if you see, I have written T length is less than S length. So if this happens, which is impossible, we have to return the empty string, because what you are trying to find should not be more than what you have given. So build frequency map of T. So here we store many a number of times each character is needed. So it's doing this T frequency and a record of a string and a number. So how this will be, for example, you have a T equal to ABC. So T frequency will be A one time, B one time, C one time. Then the step 2 comes where we initialize the window variables, which is as usual same, left pointer, right pointer. And then we have required, which means how many unique characters we need. And then we have formed, it means how many we have matched so far. So these two are important, as you will be seeing in the logs also, I have put them. And then after that, we have a window count. So what it does is it stores the frequency of current window. And it helps you to track the smallest valid window. So minimum length and minimum window will do that. It will help with the window counts to track the smallest valid window. Now the loop starts where we are gonna do everything. So here, as usual, we have a character const where we're trying to find the first character. Then after that, we move right pointer to expand the window. In all the window problem we have done, we move right to expand the window. Then we add character to the current window, and if this character meets required frequency, we increase the formed. Okay, so it means this many number of unique characters we have found. This was the definition of formed, right? So we increasing it. Then after that, okay, yeah. So after that, again we are trying. So you got, for example, the window which you wanted. Now we have to start shrinking if this happens. So what we are trying to do is, if all required characters are matched, for example, formed is equal to required, then we try to shrink. So in this, we are shrinking the window and we are calculating the current window size, and we are updating the answer if smaller window is found. And if it is found, we are removing left character from window. So this is also important. Okay. Now, while removing the left character or shrinking, you may break the smallest window or output also. So that's why we have given it like this, that if you break, the formed will have the extra value, which will lead to invalid window. And that case, we will stop shrinking and we will expand again. Okay, so it will be easier to see it in the output and input which I have given. So once this ends, we expand again to the right, which means if you have broken the correct output, then we do again add that thing. And in the end, we return the minimum window. So example run looks like this. Let's see. So you have something called this part, right? So you need ABC. So even if you see without your code running, how it should behave, which window has ABC? A, D, O, B, E, C. So till this should be your answer, which is also here. But how do we reach here? So first we expand right, we move 0, we got A, then we got D, O, B, E, C. Here we reached. We got the valid window. Everything is here. As soon as we got, we are not sure now. System or this program is not that intelligent. They think, okay, it may be I have some extra characters. So once formed, starting to reduce. As soon as it removed, formed became 2, means invalid window. Okay, so we expanded, added the A again. Then see, expand is there, right equal to 6, character 0, formed 2, we don't need, character 7, form, character D, we don't need. Okay, so then in the end, your final answer remain it as ADOBEC. So it may happen that while trying to, uh, for example, you removed A, then window does not have all required characters. Then you must be thinking, why are we shrinking? Okay. First, window becomes valid. Then we remove it, we try to minimize it, it became invalid, and that is also okay because at this point ADOBEC, ABC are all present. So formed equal to required. Okay. Then you removed A. So formed becomes 2, which becomes invalid window. Okay. So we are not trying to keep the window valid forever. What we are trying to find is the smallest valid window. Okay. So your window can become invalid, but the output of minimum length, that is ADOBC, that should be correct. Okay. So and if we think that window becomes invalid, we have stopped shrinking and we expand again. We move to right until we get another valid window. Okay. So we shrink until it breaks, then we expand it again to fix it. So this is the pattern of minimum window when we try to shrink it. Okay. So for example, to make you see correctly more, like this, you have a valid, you record your answer, you shrink it, invalid, expand, again go back till it's valid, then shrink and then repeat. This is what the loop is doing. Okay. And so this is like we intentionally break the window to explore smaller possibilities. Okay. So this was the pattern regarding our finding minimum window. So if you do like the video, subscribe to channel. Thank you.